So at AgniKul, we build rockets that take satellites to space on demand. So we have built rockets that are actually more adaptable with today's satellites. So you basically, when you're developing a new system for an aerospace product, you're sowing the seeds for 5 different manufacturing techniques. And then that becomes a starting point for something else also to grow. I'm Srinath, one of the co-founders and the CEO of AgniKul. So at AgniKul, we build rockets that take satellites to space on demand. So if you're wondering what is special about rockets, of course, rockets by themselves are very special machines, but they've been flying for a while, right? What has changed today is what they take to space. That has completely changed. So we have built rockets that are actually more adaptable with today's satellites. So that's what we built, and the idea is to make space as accessible as possible. So one thing was very clear from the very beginning, the ecosystem was very strong here, right? Only thing is there was lack of private player participation in mission ownership. So we had like ISRO do missions, or we even on the aeronautical side, right? We had all these other government programs happening, but the private industry was coming into the picture in terms of what they call as building to print, right? Wherein someone tells you exactly what is to be done and people execute. It's a very execution focused world. When we came in, the difference was we had to do a lot more design. So that was the real, I wouldn't say gap, I would say that is the change rather. So we had to create the design, and then we had to take people's support in making it come through as hardware. So that was the big difference. But overall, both the space agency and the defense industry here, they have developed a very robust ecosystem from a vendor standpoint. So when I came to start AgniKul, I was actually in the US for 10 years before that. So my view of what was possible in India was very different before I came here. The moment I landed here and understood the ecosystem, I realized if you give the right drawings, if you know what to ask for, there are people to make it for you, right? So the private player building stuff, for me in my head initially was more about, okay, we can do the design, but will there be people to execute it? The moment I landed here and spoke to people, actually the whole thing changed. I realized what probably is lacking is more on the design side, but on the realization, on the execution, there are a lot more players. So that's how my initial view was, and today also I continue to believe that design is a little more in short supply compared to execution. We have a very robust ecosystem to get things done. No, I think the biggest change is there is this whole mindset of designing in India as well that's coming up now, right? When, if I think around 2014, 2015, when the whole focus on manufacturing came into picture, when we were talking about make in India and all that, it was more about how do we do contract manufacturing, or how do we do manufacturing at the right price for designs that were owned outside, right? But today there are a fair bit of people who want to design in India. Second, there is also a fair bit of maturity in the manufacturing side. So even if you give a really complex design, people more or less know how to get it done. Now, this could be in composites, this could be in metals, this could be in electronics, doesn't matter, but we know how to get things done today. So I think that has been the major shift, and that's why I think today we are ready to take on the more complex sectors, right? Space, nuclear, quantum, all the stuff that requires a lot more precision, a lot more focus on design along with manufacturing. I think we are ready to take on all that. No, from a state standpoint, I think the first thing is a policy is clear, which is very helpful. Now, what more is needed? We need people who understand that the time cycles for these are longer. We need people to understand that business models can be built out of these. It's one thing to build a cool product. I mean, everyone loves a cool product, right? You could be an investor, you could be an outsider to the industry. But when you focus about making it a business, the other stakeholders will also have to appreciate that these are long time cycles. I think that understanding is still missing. We're warming up to it, like compared to 2017 when we started. Today I'm seeing a lot more space tech companies getting funded, right? Which is for me a sign of saying, okay, people have started to accept that you can build business models out of space tech. Similarly, I'm seeing here and there some deals happen on the nuclear sector side. I'm seeing deals happen on the quantum side. So all of that for me is a sign of people waking up to that, but that is still, there is a gap. I think a lot more people will have to warm up to the fact that good engineering can be conceived in India. Got it. So let me just take this might be a slightly longer answer, but let me take that effort for it because I think that will give a broader context on the sector also, right? So rockets have been flying forever, right? 1960s, 1969, humans as a species put a human on another, heavenly body. So what is new in rockets? The physics of it has remained the same, right? You're always squeezing out a little bit more, but that is there. So, but what has happened in the last 40, 50 years is the satellites or whatever is riding as cargo on a rocket, that has completely changed. In the end, a rocket is simply a transportation system. It just takes stuff from Earth and puts it in some orbit in space. That's all any rocket does, right? So, what is riding on the rocket has evolved. That has evolved because of the electronics industry and all that. So, the net conclusion of that part of the story is the person or the cargo that is getting a ride has changed. They are now operating in a different place in space. Their size is reduced, their mass or their weight is reduced. But rockets were still stuck in the past. So we spotted an opportunity at AgniKul where we felt, hey, why is no one building a rocket for today's satellites? Why are still rockets stuck in the past? So then the obvious answer was, okay, why can't we just take a big rocket and shrink it? Right? And we actually attempted that. And in that process, the first thing we learned was you're fighting this concept of economies of scale. When you take something big and you're trying to shrink it, you immediately end up into this whole list of inefficiencies because you're actually not taking advantage of size, right? So then you're fighting this big concept of economies of scale. There is no way you can fight it. I mean, that's a well proven, understood model. So the only way to get around that, to make something meaningful at a meaningful price at a smaller size, is to figure out new tech, is to figure out new designs that work at this size. So that got us into this pursuit of, okay, we'll build rockets, we know the physics of how to build a rocket, but the 50 years of tech that was used for building rockets is not going to make a rocket economically viable if you simply shrink it. So that led us into exploring manufacturing technologies, exploring design technologies. So 3D printing actually came up with that, right? The only way, according to me, and we have researched a whole bunch of manufacturing techniques, the only way in which you can make a rocket engine that is small or in terms of thrust capacity, lesser thrust capacity, work at a unit economics level, even though it's small, make it comparable to a large engine, is by using 3D printing. So that's where it came. The team actually pushed it to such a point where the entirety of the rocket engine is 3D printed in a single shot. So we call our rocket engines single piece rocket engines, right? Meaning what comes out of a 3D printer is a fully made rocket engine. There is no more welding, no more fasteners, no more tightening of bolts, nothing. What comes out of a printer is basically ready to be depowdered and just put onto a rocket. So that aspect of it is what I think we had to figure out to make the economics work. So that's how 3D printing came into picture. One point, I know you asked about 3D printing, but I think on a bigger context, a lot of technologies exist that we had to figure out from scratch to make the economics work at smaller scale. So we are very clear from the beginning, we don't fight a concept as strong as economies of scale. We work around it, and new technology was the only way to work around it. It was a hard question, to be honest, and we usually go on this mode of, okay, let's build everything from scratch. But then you quickly realize you're not going to get to the target quickly if you're not riding on what's already out there, right? So you basically have to go to the first principles all the time, and that's easier said than done. But always ask the basic question of, I know technique A exists to do something, I could probably figure out a technique B, but why should I figure out technique B? And ask that question as many number of times as possible, and ask it with people who are not too much of an expert in the industry. Because one thing I've realized is the more you are in an industry, the more you are set in your ways of thinking, right? You think this is how it works. You're so sure of only a few styles in which things get done, and that actually becomes an impediment. So one thing that has worked for us is we have a relatively young team, right? People who have not built rockets for a living for a longest period of time. We sandwich them with people who build rockets forever. And that creates some interesting debate, because sometimes the questions that almost look like, it will be like almost an incredulous question, like a naive question, but sometimes the real answers lie in those questions. So I think that's how we are able to make the choice of, should we create from scratch or should we take what is there and add on to that. So, and process renovation is everything in rockets, I think. Almost every rocket manufacturer in the world has gotten a design that works, gotten that to that point, right? Because they test things on the ground. So, yes, design is very hard, by the way, but design is testable in a way, right? If there is such a word as testable, but you can basically predict and match your results with your what the predictions are before. Now the real challenge is, can I repeat it hundreds of times? Like, let me take the most commonly flying rocket in the world today, SpaceX, right? And we talk about them doing 100 launches, 135 I think last year, 2024. And a lot of people speak about a lot of things about SpaceX. I think the most spoken about SpaceX thing is the reusability, where they bring a part of the rocket back and so on. But according to me, the bigger marvel that they have actually done is make sure that 135 rockets roll out, or 135 launches roll out every year without a process flaw. So how do you make that happen is actually the real bread and butter of rocket engineering. So we use three techniques, right? One is we use this thing of 100% tracking for 100% of the parts. So everything about, let's say it's a screw, we track every bit of the screw from the moment it enters AgniKul's gate all the way till it lands up on a rocket, 100% of the time. So at any point in time, say for example it entered 5 days ago, and someone asked me, okay, yesterday where was the screw? Someone should be able to tell who was the last handler of the screw, where is it stuck, where is it going. So we invested in ERP tools for that. We invested in making our own software for that, right, tracking for that. And the hardest part, getting the culture for that right. How do you get a group of people to actually care about process innovation? Is first of all by highlighting that process matters. And that is actually much harder than any other system you can put in place. So one is obviously the 3D printed engine, where the entire engine is a single piece of hardware. Two other things that we had to do to make the rocket economics work rather. One is this Autopilot, right? So we built an Autopilot algorithm from scratch, where the entirety of the rocket's trajectory can be played with just a couple of engines. We don't have a fixed vehicle configuration. So the way a rocket maneuvers itself into a particular trajectory is by actually shaking the engines, right? We call that gimbaling, right? So the rocket engines are gimbal, like how a camera on a gimbal would be, and that is what allows the rocket to pitch or yaw or roll of something. Now, the way in which rockets are usually controlled is by having a fixed algorithm. There are a fixed number of engines, fixed thrust, and these things are actually moved here and there, and then you're able to maintain a particular trajectory in space. We came up with a templatized version of it, where I could fly the rocket with 4 engines, 5 engines, 6 engines, 7 engines. So the vehicle itself is sort of scalable, both upward and downward. And the Autopilot is also scalable along with it. So that's one thing. The other thing is the mobile launch pad, right? We don't count on having a fixed infrastructure, or a land or something to go and launch from. Everything about the rocket and everything about the launch pad, including the mission control room, is mobile. So you can just go from place to place wherever you get permission, put up your installation there, get the launch to happen, wrap up and come back. So that's another big concept that we had to crack in a way to make the economics work, but I'm also happy that the team did it. So one good thing is space, at least, or most deep tech sectors are very passion driven sectors. You have a lot of people who want to do only that. But I also think a lot of people are very influenced by what they study in college and all that. That's only half the story, right? So we very quickly, in the first 2 years of AgniKul, we very quickly realized college education, or at least non-industry education, can only get you 50%. So the remaining 50% you need to learn it fully on the job, right? So which means you need people who are in that student mindset of learning, while at the same time in the product manager mindset of delivering. So we started solving for that. We, more than focusing on are you able to design a rocket engine, our basic questions were in basic math, basic physics, logic, logical thinking, and beyond that it was all about attitude. Will this person be able to put himself or herself in the shoes of a student, while at the same time also in the shoes of a project manager? So that's what we try to solve for, and that just solving for that gave us the right kind of people to work with. Luckily, I think India, I mean, there's so many people who also fit that bucket, but it is still for us the typical hiring ratio has been 1 in 40, right? 1 in 40 or 1 in 50 people make it, and that is the hardest part of the hiring part also. Grooming the talent, I know I'm answering out of the options you gave me, but I think that has been the hard part, to get that culture of, like for example, right, like again, in a startup I've generally seen a lot more focus on design, a lot less focus on quality. Quality is not as cool as design, right? Unfortunately, that's how it is, and it's also a thing where you sort of need to have that maturity to think about quality in a way, because designs will work, but then will it work 100 times is a question. So to find people who are good designers but who are also quality conscious, that was hard. How many people do we have who are not too obsessed about the design but are also obsessed about the design working every single time? So that was actually the hardest part of first finding those people and also grooming such people. I think components, particularly at least in rockets, 90-95% is in India. So it's not a problem. Maybe for a couple you'll have to go outside the country, but that again, because ISRO has done that, the vendor ecosystem is quite, the knowledge is quite out there, so that's not a problem. Infra, we solve for that very differently. We solve by working with academia partners. So in this ranking of people, components and infra, I would still put people as the top. Yeah, no, I think that has been the biggest positive thing. I think in 2017, so we started in 2017 December, I was never able to answer this question of whether it's legal to launch a private rocket from India with a clear yes or no. It was always like, yeah, it is possible, ISRO will allow us one-off, we'll have to go through IIT, all these things were there. So we knew a few missions are possible, but can I build a SpaceX in India? That was not very clear until InSpace was announced, right? And I think that has been a big change. You get 3 levels of validation there, right? First, global customers take this whole concept seriously. It's not like a bunch of people playing with hobbies, because the government has created a framework. Second, when you talk to some of the largest vendors, right, these people, because there's a policy framework, take you seriously. Otherwise, they're looking at it like a student project. Third, I think, is the investor community, because the biggest risk for an investor that, even if you have the best of the best founders and the best of the best teams, you may not be able to control policy, right? But when policy clarity is there, then suddenly investors are now focusing on business case and people, right? So that makes it also easier for investors. So I think it has opened up all these gates. I would say there is still a way to go in terms of making space a more regular thing in India, but at least all the foundations are in place. We have something for launch pads, we have something for geospatial data, we have something for rockets, we have something for satellites. Everything, the first draft of the framework or the first final policy itself is in place. So there is always scope for improvement, but there are very few areas where you're completely lost. So in-house was all about testing facilities, right? We knew that the manufacturing facilities are available in India. it's well hidden. You don't have a global database, but you can get that, right? But unintentionally hidden, by the way. It's not like intentionally hidden. It's just that it's not, people are not, forthcoming in putting out what they're doing. So you sometimes don't realize where the best precision manufacturers of India are. And you won't believe that they're hidden in some of the most unexpected places in India. But it is there. So the real thing that I think was a challenge was for this community to come together and do this whole work. Because I felt if you know where to go, you can build stuff. But who will test a rocket engine? I know to design a rocket engine. I know if I have to go outside, I can make this rocket engine. But where will I fire the rocket engine? That is where we had to say, okay, let me raise money basically for building testing facilities, and that's where the money also has gone for. Even if you look at our own AgniKul's journey, it has all been about testing facilities. It's more about being professional, about communicating timelines, communicating systems, developing a robust documentation history for what you're doing. All because in lab, all of these things are considered secondary, literally, right? You can fumble around a bit. If someone asks you for the right version, you can always say, hey, I've not updated this version alone. This document alone is missing. But when you upgrade yourself to go to the point where you're working with professionals like ISRO, like for our launch we did last year, the launch pads, radars had to be used from ISRO. And then all the other systems were ours, right? So we had to have that interface point with ISRO. And ISRO, because of how good they have a very clean set of requirements. They talk systems engineering in a way like I've not seen anywhere else, right? And when you suddenly ask a bunch of people who have done a lot of design, but have not done much systems engineering, you see that gap. So that I think is the big difference. And in a way, again, as I already said, it is not considered the coolest of things. Documentation is never cool, right? But we had to come up with a way to say documentation itself is like a product. So it's not enough to make a rocket engine, it's also necessary to make a document about how to run the rocket engine as good as the rocket engine itself. And that's how we have been able to match that level of going into the professional world. Yeah, so it actually goes hand in hand. You can't say you're only in R&D phase or only in execution phase. You need to put out as many tests as possible, right? The only way to really fly a rocket or to get a rocket ready to fly is to test it n number of times. You just need to know all the quirks. Every rocket engine or every rocket component has this, for lack of a better word, like a small personality to itself, right? It will take this extra half a second. We've all seen it in our vehicles, by the way. Even if you drive the exact same car from the exact same manufacturer, you will slightly find a difference between two cars, right? That is there in every rocket. So you will have to figure out that nuance about your vehicle. So just testing. In parallel, you also do R&D because you're looking at a longer time cycle, right? If today something is in R&D, I know it will take me 3 years to get it to space. So I start doing that work, while at the same time I know in 6 months I have a flight. So that also I'll have to be working. That is fully onto the testing phase. Definitely, I think so. I think space will be a nice sector to start because it's very broad, right? It touches everything. It touches the composites world, it touches the metals world, it touches alloys, it touches electronics, and it touches anything that you can think of from a hardware standpoint. So I think because it is being sort of led by aerospace, and I'm here going to make the boundaries a little gray and also include drones, also include anything in the flying sector, right? They are all such interdisciplinary engineering areas where you never focus on only one thing. So you basically when you're developing a new system for an aerospace product, you're sowing the seeds for 5 different manufacturing techniques, and then that becomes a starting point for something else also to grow. So I think that way we are at the cusp of a big manufacturing wave where it will be led by a lot more of design IP and so on. I think that has started in a way. Yeah, so I think it's going to require capital, but the policy is out there. So first I'll say what is there, right? Policy is out there, know-how is there, and in some ways people are also there. You may have to hunt a little, but you have those three things. What is, I think, going to be needed is the right kind of financial support for people, is the right kind of patience capital, and more importantly, general trust from the rest of the community, not only investors, that true innovation is possible in India. The goods, there is a sign of that happening right today. I'm seeing a lot more people do aerospace course outside the country, and then they're coming back to do a job here. When I wanted to come back, there was no company to employ me, right? But today I think some of those people are actually in AgniKul. So I think that is opening up more of this. So I definitely think we are in the right track there in terms of that kind of manufacturing. I would say maybe a little bit on the nuclear side, but aerospace itself is actually very broad. You're talking drones, you're talking rockets, you're talking satellites. But outside of anything that flies, I think nuclear would be definitely something where we will have a head start on. I'm also seeing a lot of interesting work happening on the crypto side, but I don't mean in terms of the Bitcoin type of crypto, but building servers, building actual electronics hardware around it, right? I think so. In a way that also merges into the whole robotics side a little, and we are seeing at the government level so much initiative for semiconductors, right? We are seeing subsidy after subsidy happening for actual silicon fab in India. And these are great initiatives. Nothing will immediately pay off, but over a 5 to 10 year period, these are great. Also seeing energy pick up, right? So that's also an interesting area. Again, these are all always from an engineering and manufacturing standpoint, one step away from aerospace. So that's why I think that by starting off with space tech, we have sowed the right seeds everywhere. So I've been a space enthusiast all my life. So for me, going into space was like the natural thing. It took me a couple of diversions though. I did an electrical engineering degree, then a financial engineering degree, worked in Wall Street. But throughout this journey, I think I was always solving for, okay, when can I or how can I get into space tech? It just took this course that I had to do this another degree after quitting my job on Wall Street, and then did this whole search across academia, and only then realized that okay, you need a testing facility or someone to support testing facilities to build rockets or any space tech hardware. So all of those things fell into place in a way after a lot of searching. It was not easy, a lot of cold calls, a lot of networking to find the right kind of people. But I think the interesting thing about starting up when that is not a common thing in India, at least in that sector, was that in a way no one could, a lot of no's, but in a way no one could also clearly say why it won't work. It was all these preconceived notions that people had that, or in the most positive way you could say, people are concerned that it may just end up going nowhere, right? But if you had some logical reasoning behind it, it was also not that hard to convince people. So that's how our journey itself has been. It's good that today we are seeing a lot more of those seed level initiatives come up. I'm seeing that across space tech. At least I'm aware of 2 companies in India who are trying to do manufacturing in space. That's super cool according to me, because now you're already starting to look at space as a platform. Space has become like thinking of space as a destination where you go to take a photo, or going there to provide internet or communication. That almost is sort of becoming like, okay, that industry has matured, 10 billion a year of revenues out there, let's try to make that. That is one thing. But now you're seeing like these guys go up there to take advantage of space as a platform, right? You have vacuum there, you have microgravity if you're on orbit. What can you do with those things? I think that has already started. I think I've become a lot more understanding of how people work. I think even though when I got into it, it was very, in a way, very shallow, I would say, I don't know. But it was all about, okay, can I build a rocket? I like building rockets, can I go build rockets, right? Then I realized there is a thin line between building rockets and building a company that builds rockets. So that itself then became about, okay, how do I enable a group of people to build rockets? then which meant, okay, how understanding how can you get these people together, because anything in space tech, and of course I can talk a lot more about rockets, it's so multidisciplinary, so you're always dealing with very wide range of knowledge base in terms of experience, in terms of skills and so on. So like for example, you need equal contribution from a postdoc and from a diploma person, right? And how do you get them to work on the same platform? How do you get them to actually, both of them to truly feel that they are going to be equally contributing to the rocket? Those kind of challenges is, or at least those kind of people skills is what I think I have gotten a little better at. Understanding people, understanding how to make them work in this kind of a setup. I think that is how it has changed me. I also always tell my team also this, right? When you build an aerospace product, or I'll talk about Agniban, our rocket, you're thinking you're building this and you're putting your signature on it, but the rocket is also actually building you, right? It is a process of you building the product and the product building you. And the more open you are to that, the more open you are to allowing the product to change you, actually makes the product also better and you also better. So I think only those kind of people actually make it big in this sector. That's why even though you have so many people in the community, there are these stellar stalwarts that people speak about, right? And I see that as a common trait across these people. They have allowed the product to change them. So that's what I tell my team, that's what I tell myself too. I think the aspect of repeatability, that will, if you have everything the same, all things the same, and you build a rocket and you fly it, you fly rocket 1 and you fly rocket 100, will they do the exact same thing? That I think is a lot more underestimated from the outside world, at least when it relates to India, because here we are all a lot more about jugaad. In a good way I'm saying, right? We are more innovative than process oriented, and that sometimes is a problem for aerospace. So that's what I think people sometimes may miss about what is hard in India.